We're still in Chapter 5, Section 7. This is the second video, and we're looking at quadratic functions. And very quickly, without a lot of explanation, I'm just going to give it to you. A quadratic function is of the form ax squared plus bx plus c. X is my input value, okay? A, b, and c are constants, or numbers, all right? Now we're going to look at a table, excuse me. We're going to try and figure out what quadratic function would go with these inputs and outputs. First thing is test it. And if you look at this, nothing is consistently being added, so we know it's not linear. Okay, it's not being consistently multiplied, so we know it's not exponential. So we have to go to the next guess. And there's one way to test for this. You'll notice I've got two delta columns, right? To go from 3 to 5, I add 2. To go from 5 to 11, I add 4. To go from 11 to 21, I add, oh, I'm sorry, this was 6, not 4. I add 10. And to go from 21 to 35, I add 14. Well, it's not consistent, is it? But the second column tells us something. To go from 2 to 6, we add 4. From 6 to 10, we add 4. From 10 to 14, we add 4. Notice, if we do it a second time, we get to consistency. And that's your clue that this is a quadratic function. And what makes it quadratic is that we have an x squared term. That's what tells me it's quadratic. And if I'm looking in a table, it's that second column of deltas that becomes consistent. That's what tells me I'm looking at something quadratic. All right, so I'm going to make a note here. It takes a second column, delta 2, to find a consistent change. Okay, this shows that you have a quadratic. Shows it is a quadratic function. Okay, all right, so what I want to do now is I want to begin breaking this down. So what I'm going to do is I'm going to go when x equals 0, okay, so that you can't see it. When x equals 0, a to the 0 power squared plus b to the 0 power plus c equals 3. Now let me show you what I just did. I took my x as 0 and I plugged it into this equation. So ax squared plus bx plus c. If I take out the x's and put in zeros, I get this. But I know that when x equals 0, I get 3 out. So I've got this. Now if you think about this, 0 squared is 0, so that term goes away. B times 0 is 0, that term goes away, and I'm left with c equals 3. So now I already know one of the values of a, b, and c. Now we have to do another one. When x equals 1, so now we're going to go down a line in my table. I know that a times 1 squared plus b times 1. Notice I took the x's out of the equation and replaced them with 1. Plus c, well, I already know what c is. C is 3. So instead of writing a c, I'm going to put a 3. And I know that when x is 1, I get 5 out. So this equals 5. If we simplify this, we get a plus b plus 3 equals 5. Now I'm going to subtract 3 from both sides and I end up with a plus b equals 2. Now I need that, but I'm not ready to use it. Now we need one more line. When x equals 2. Now we're going to put 2 into that equation. A times 2 squared plus b times 2 plus 3. I'm still using 3 for the C value. I know from the table that my output is 11, so this equals 11. Now I'll simplify this. This gives me 4A plus 2B plus 3 equals 11, and I'm going to subtract 3 from both sides, so that gives me 4A plus 2B equals 8. And I also notice that everything here is divisible by 2, so to make my life a little easier, I'm going to divide every term by 2, and I get 2A plus B equals 4. Okay. Now, notice I have two equations in AB. All right, I have A plus B is 2, and 2A plus B equals 4. So I'm going to do a system of equations. I've got A plus B equals 2. I've got 2A plus B equals 4. I'm going to subtract those two. What will happen is the b's will get canceled out. So I get negative A equals negative 2, so therefore A equals 2. Okay, so now I know what A is. So I'm just going to take 2 and probably put it back in that equation to be the easiest one to work with, where A plus B equals 2, but I know A is 2, so 2 plus B equals 2, which leaves me B equals 0. Okay, so I have an A, I have a B, and I have a C. And I can write f of x equals ax squared plus bx. You can't see that. F of x equals ax squared plus bx plus c, and now I can put those number values in. F of x equals 2x squared plus 0x plus 3. Now obviously, take out the 0x and you have f of x equals 2x squared plus 3. All right? Now the math is finally getting interesting, you guys. Look at that. One problem took an entire page. That's when we know math is getting interesting. Okay? You have to be methodical in your work. Okay? Don't think you can get this done by doing a bunch of chicken scratching on the side and not showing your work and trying to do it all in your head. It's not going to happen. You really do have to look at the second column. Make sure it's quadratic. Look at when x is 0. Look at when x is 1. Look at when x is 2. Show the steps. Do the system of equations. Calculate the values. And then plug it in. I'd like to do one more. So here we have the equation, or the function table. And it goes 5, 6, 9, 14, 21. So to go from 5 to 6 is plus 1. From 6 to 9 is plus 3. From 9 to 14 is plus 5. And from 14 to 21 is plus 7. So nothing consistent, but if we look at a second column, we notice we're adding 2 every time. So I know it's quadratic, right? So I know I'm going to look at when x equals 0, a times 0 squared plus b times 0 plus c equals 5. When x is 0, I get 5 out, okay? These two terms cancel, and I'm left with c equals 5. So I need that. Now we're going to look at x equals 1, so a times 1 squared plus b times 1 plus c, but I'm going to put 5 in for c, equals, and when x is 1, I expect to get 6 out. Simplify that, that's a plus b plus 5 equals 6, or a plus b equals 1. Then we'll do it when x equals 2. When x equals 2, I get a times 2 squared plus b times 2 plus c, but c is 5, equals, and I expect to get 9 out. 9. So 4a plus 2b plus 5 equals 9. And I'm going to subtract 5 from both sides. 4a plus 2b equals 4. And I notice again that these are all divisible by 2. So to make my life a little easier, divide every term by 2. And I get 2a plus b equals 2. I'm going to take this equation, and write a system. A plus B equals 1, and 2A plus B equals 2. If I subtract, the b's will cancel. Get negative A equals negative 1, or A equals 1. Take A equals 1, put it into either one of these, it doesn't matter. I'll put it in the first one, because it looks like it's the easiest to use. Put in 1, 1 plus B equals 1, B equals 0. Okay, so now I can write the equation. F of x equals ax squared plus bx plus c, and I plug in those numbers. F of x equals 1x squared plus 0x plus 5. I can do some simplifying and write this as f of x equals x squared plus 5. And there's the function. All right, you guys, these are complicated. So take your time, go step by step.